In this next section of the chapter, we're learning about a concept called enthalpy. Before we can get to enthalpy, we need to talk through a few more definitions. Internal energy, which we abbreviate with a capital U, is the total of all the possible kinds of energy present in a substance. These include translational, vibrational, and rotational kinetic energy, as well as potential energy from intermolecular forces. The first law of thermodynamics tells us that energy can't be created or destroyed. It's only converted from one form to another. We can express this in equation form, related to the system and the surroundings. Delta U for the system, that is, change in internal energy for the system, plus delta U for the surroundings, change in internal energy for the surroundings, equals 0. There can be a movement of energy from the system to the surroundings or from the surroundings to the system, but there is no net change. We can rearrange the equation to say the delta U of the system equals the negative of the delta U of the surroundings. This is a similar equation to Q of the system equals negative Q of the surroundings. But with this, we're talking about all of the types of energy, not just heat. We're going to use the equation delta U of the system equals Q plus W, where Q is heat and W is work. If we add up the heat and the work, that gives us the total energy for the system. This equation is deceptively simple. It seems like we're just going to be adding two numbers. The tricky part is that we have to identify the signs for each of those numbers. We're going to be working with word problems, and a sign may not be explicitly stated in the word problem. We have to think about what is happening with relationship to the system and the surroundings. We've already talked about the appropriate signs for Q. When heat is going into the system, that is, absorbed by the system in an endothermic process, Q is a positive value. When heat is released by the system, it's going out of the system, being subtracted from the system in an exothermic process. The Q is negative. We have similar sign conventions for work. When work is done on the system by the surroundings, we give W a positive sign. You can think of work as being added to the system. Work is done on the system, so we give it a positive symbol. If work is done on the surroundings by the system is doing the work. The system is sort of releasing work. Work is going out of the system, so we give it a negative sign. We can look at our word problems, and based on what is happening to the system or the surroundings, we'll give it a positive or negative sign for the Q or the W. Again, everything is defined based on what's happening to or with the system. If there's an increase in work or heat for the system, the delta U for the system will increase. If there's a decrease in work or heat for the system, the delta U will decrease. What is the change in internal energy for a system that releases 71 joules of heat and does 3.1 times 10 to the minus 2 kilojoules of work on its surroundings? Be careful with the signs and be careful that the units are the same as each other. Anytime you're trying to add or subtract something, really for any of your calculations, the units need to be consistent. Is the answer A, 40 joules, B, 102 joules, C, negative 102 joules, or D, negative 40 joules? The correct answer is C, negative 102 joules. The first thing you're going to have to do is get the units to be the same as each other. I would change the kilojoules of work into joules by multiplying by 1,000. We end up with 31 joules, but we don't know the signs yet. We have to closely read the words in the word problem. It says that the system releases 71 joules of heat, so 71 joules of heat are going out of the system. The 71 is negative. It also says that work is being done on the surroundings, that is, by the system on the surroundings. That's also going to be a negative value. We have negative 71 for the heat and negative 31 for the work, making a total of negative 102 joules.